Okay, so yesterday we did the first four. Now I'm going to do four more. Then I recorded yesterday's and sent it to you. So today's we'll see if that goes as well. Okay, so K, call the wave number because it tells you how many complete cycles are between 0 and 2 pi. So this was 0 and this was 2 pi. And you saw this. K is 2 because there's two waves. I'm recording here. So if there's two complete waves or cycles between 0 and 2 pi, K will be 2. Okay. So when you're trying to figure out what K is, you can always take, if you want to figure out the cycle, you take 2 pi divided by K. That'll give you the length of the cycle or the period. So this affects the period. This affects the phase shift. Okay. So we don't have that yet. That's just the full parameter. Okay. So if I look at this here, this tells me my K is a half. What that means is between 0 and 2 pi, you're only going to see half of the cosine curve. So just the first half. So what that means is if you think about what your cosine curve normally looks like, normally your cosine curve might look like something like that. So what this half is telling you is you're only going to see this part. There's a better way to think of it. That half is K, right? Because it's a half, because it's a fraction, you have a horizontal stretch. So you take your K, your X values, and you multiply by 2. So my max is at 1. See this point that's 2 squares away? It should be 4 squares away. You see this 0 that's 3 squares away? It should be 6 squares away. Look, this was just 1 square. The gap is already doubled. This minimum that's at 6 squares should actually be at 12 squares. So the next point should be over here. How do you know this? Because you know intimately the cosine curve. You know there's one here, so there must be one there. You know there's one 4 away from here, so there's one 4 away from there. And that is cosine of a half theta. Notice it's just the first half and it's stretched by 2 because it's always 1 over K. So the key thing is, remember that K, the wave number, tells you how many waves are going to be between 0 and 2 pi. So if it's a whole number, there's one wave. If it's a fraction, that's just that part of the wave. So again, in the second one, negative sine half theta, you're only going to see half of the sine curve from 0 to 2 pi. So if it helps, you can always put your base function first. So my zeros, sine, my max, my min, got a point here, got a point here, got a point here, got a point here. So you can see that. That's your sine curve. So we've got a negative and we've got a horizontal stretch. So this point here, the negative of 0 is just 0. So you've got to do two things at the same time. Okay. So I would recommend you do the following. Just let me help you out. You see how this is sine theta? So we want minus sine theta, right? So first thing we do is draw the negative of this. So there's my original sine theta. And there's my reflected sine theta. Okay. Why did I do that? Because I know that I've done minus sine theta now. The next thing is I got to involve k. K means I take my x values and multiply by 2. So minus sine theta goes here. Minus sine half theta will go here. This is at 3 squares, so it should be at 6 squares. This is at, okay, so we've got that one, we've got this one at 5 squares, so it should be at 10 squares. You see how this mirrors with that? That's the symmetry there. And then this one, which is at 6, should be at 12. Okay, when you draw that, you will notice that it's basically the first half of sine flipped over because of the negative and stretched because of the k, which is 2. You good so far? Sine of a half theta. This means between 0 and 2 pi, we'll just have the first half of sine. But now, since you've already done sine a few times, you know that your sine curve basically is this one. Sine of a half theta will take all my x values and multiply them by 2 because it's a horizontal stretch of 2. So 0 is still at 0. 1 becomes 2. 3 becomes 6. 5 becomes 10. And 6 becomes 12. Let's see if we can do cosine of half theta since we've already seen it without drawing the whole curve. Here's how you could cheat at that. Here's your max. Here's your min. Here's your max. Correct? For half theta, everything will get stretched out by 2. So we have a 0 here, and we have a 0 here. So when I multiply this by 2, it'll just be this. When I take 3 and multiply it by 2, it'll take me there. When I take 6 and multiply it by 2, it will take me there. Okay. Are we okay with that? We're just doing 2 sheets today. Are we? No, no, we're doing 4. So 2 sheets on both sides. Okay, we're good with this one? Okay, so now we're going to do some combinations with A, K, and C. Next time we'll throw it. All right. So if you look at this, I've got 5 sine 2 theta plus 5. So instead of going from 0 to 1 and 0 to minus 1, I'm going to go from 0 to 5 and 0 to minus 5. Okay. Now, I'm going to put some numbers on the board to show you what's going on. You don't need to write this down, but this is how you figure it out. Okay. If I had my my regular sine theta, I would go from 1 to 0 to minus 1. But because of the 5, it's going to go from 5 to 0 to minus 5. Everyone okay with that part? This plus 5 gets added to all the y values. So minus 5 plus 5 becomes 0. 0 plus 5 becomes 5. 5 plus 5 becomes 10. So that means my graph is going from here to here. Anyone up with me? And this means between 0 and 2 pi, I will have 2 sines. Okay, 2 sine curves. So you see 5, that's my midline. So that's where my sine starts. It'll end here and here. So one sine wave, another sine wave. Okay? Now this one's a little bit dicey because you have to go through the middle here, but that's fine. So there's the mid there, there's the mid there. My sine curve will look like this. Two sine curves that go from 0 to 10. And that's how I figured it out. So if you miss that, you know that sine theta normally goes from 1 to 0 to minus 1. The 5 changes that. 5, 0, minus 5. When you add 5 to all the y values. So 5 becomes 10, 0 becomes 5, minus 5 becomes 0. So now you know your graph goes from 0 to 5 to 10. The 2 tells you from here to here, you should have 2 sine curves. So you've got one sine curve, second sine. And then what happens on this side? It's just the same thing. So between negative 2 pi and 2 pi, you should have 4 cycles. 2 cycles between 0 to 2 pi, 4 cycles between the whole thing. And I wanted to show you the whole thing because sometimes the book asks you 0 to 2 pi, sometimes it asks you 2 pi. So just so you have options there. So I'm not that good that I came up with all of this. I saw it in a workbook that they had all these different graphing sheets. And I was like, oh, that's a good idea. So I did these on Smartboard. And when I teach grade 11, I use the same sheets, but instead of radians, I just erase them at degrees. So it's just a little bit better than drawing them on the board there. Okay, so let's look at 5 cosine 2 theta plus 5. And the reason I used a similar function is because now that I've explained this business, you'll notice that it's easier for cosine. Cosine goes from -1 to 0 to 1. Because of the 5, that changes to 5. It's still 0 minus 5. When you add the second 5, 5 plus 5, 10. 5 plus 0, 5. 5 plus -5, 0. So that tells you your graph goes from 0 to 5 to 10. The 2 theta means that between 0 and 2 pi, you will have 2 complete cycles of cos. Cos starts at, this is my starting point because it's my midline. You understand? So this is where you start here. Oh, that's a line. How much fun that is. Okay, so it has to start at the max. So there's the first point. It's going to do a complete cycle and it's going to end here. And another cycle and end here. The minimum will be over here. Minimum will be over here. And then the 0 will be there, 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 there. So when I draw that, it should look like a cosine curve that's opening in its standard orientation, opening up, and between 0 and 2 pi, you have 2 cycles. So when I have a whole number for k, like 2 or 3, that means I have 2 complete cycles or 3 complete cycles between 0 and 2 pi. When I have a fraction, that means instead of a whole or multiples, I'm going to have just a part of 1 cycle. So if you look at question number, there's no number. The next one, it's 1 over 3. That means between 0 and 2 pi, you're only going to see 1/3 of cosine, just 1/3 of the wave. So let's do the same thing we did before. I know sine goes from 1 to 0 to -1. Because of the 2, it goes from 2 to 0 to -2. And then you're minusing 1. 2 minus 1, 1. 0 minus 1, -1. 2, minus 2, minus 1, minus 3. So you can see the gap between them is 2 lines each. So this tells you the mid, the high, and the low. So your mid, -1, and my thing is 1/3. So my k is 1 over 3. 1 over that is 3. So I've got a horizontal stretch of 3. So I'm going to take all my x values and multiply them by 3. So my sine curve normally might look like this. So there's my 1 point, and that's 1.5 squares, because it'll be half of 3. Do you see that? Just for the sine theta. But this is 1 over 3, so I've got to take these number of squares and multiply by 3. So the 1.5 point will go 1.5 3, 4.5. There's my max. These points are a little bit harder to see, but they can still work. This 0.5 is at the halfway. You know why you know that? Remember your sine curve? Okay, so this is 90. Yes? 1/3 of that is 30. Yes? 30 is where you have the 0.5. So 0.5 of the amplitude is 1/3 between the 0 and the 90. So when you go to this, here's your 90. Here's your 0. Your 90 is at 1.5. 1/3 of 1.5 is 0.5. So you know that this is 0.5. 0.5 times 3 is 1.5. So this point moves from a half to 1.5. You curve. That's the 0.5. But this is my mid, so okay. Who else have I confused besides myself? We're good with the base sine curve where it is? Okay, so we're good with the, this is my mid. That's my high, and -3 is my low. Okay. Okay, I'm just going to start here. So these are my values. So that's my mid, -1. If I was doing a regular sine curve, I'm just going to follow these here. My regular sine curve would go from -1 to 1 to 0 to -2 to -2. Are those dots in the right places? Or just 2 sine theta, not the 1/3. Okay, I'm just doing 2 sine theta -1. So you can see here that that's not right. Or maybe I'm not. It's 4 this way, it's 4 this way. So that curve that I've drawn so far is this. Do you agree with that? I haven't done the K. I've just done one sine curve that has an amplitude of 2 and a vertical displacement of -1. Now I've got to apply the 1/3. What that means is I have to take all my x values and stretch them by 3. So my max, which is at 1.5, should be at 4.5. And between here and here, Here's the half point. Okay. Now, this one, I need you, it's difficult to see, so I'm just going to try and do it as slowly as possible. You need to remember that 30 is 1/3 between 0 and 90. You guys get that? The 0.5 mark is at 30. So when I go to this graph, from -1 to 1, which is the top half of that is this line. Do you agree with that? So this is at the halfway point. It's 1/3 between 0 and 90. So this is a half. When I multiply by 3, this point will go to 1.5, which is there. This point, this is 1.5, 2.5. When you multiply 2.5 by 3, you get 7.5. So this is going to be over here. It's off the graph. So this part won't even come onto your graph. Okay? So when you draw it, we're going to go through this point, and you're going to start coming down, and that's about it. It is one of the dirtier graphs. But it'll help you understand that one much better. Because that's much easier than this one because of the 2. Okay? So even if you're confused with this one, let it sit for a couple of days and then we can do it again. If we go to the cosine is a little bit easier. Instead of going from 1, 0, -1, -2 times 1 is -2, -2 times 0, -2 times -1 is 2. Okay, so it's going from -2 to 2. Then you've got this +1 business. So what does the +1 business do? -1 becomes -2 plus 1 is -1. 0 plus 1 is 1. 2 plus 1 is 3. So it's going from -1 to 3. So I'll just try to help you by putting some lines there. Here's -1. And here's 3. So there's your max and your min. Okay? For -2 cosine half theta plus 1. Now we've got to do the half theta. What that means is from here to here, instead of 1 cosine, you're going to see 2 cosine waves. Okay? So this is, sorry, let me just restate that again. Because my wave number is k, from 0 to 2 pi, instead of seeing 1 complete cosine curve, you're going to see half. So remember that we're dealing with negative cosine. So negative cosine might have looked like that. Because of the 2, we're going to multiply because of the half, we're going to multiply all the x values by 2. So 1.5 goes to 3. 3 goes to 6. And so your curve would look like you know what that finger was for? This is positive cos. We want negative cos because of that. Right? So my x value is 1.5. 1.5 times 2 is 3. My max happens at 3. 3 times 2 is 6. And so when you draw that, So basically, the first half of cosine flipped over. Okay, I want to do something a little bit different rather than the other graphs, because I think if you just do graphs all week, it takes too long to get to the equation. Okay? So I'm going to do a little preview of the equations, and then tomorrow I'll teach you the equations at the grade 12 level, and then Thursday we can do. Okay? So instead of doing 8 of these, I'm just going to do 4 there, and now go to the equations. Okay. I'll give you work tomorrow. Let's try. I gave you the sheet, right? Let's try the questions. They're not. All right. So here's the situation. 2 sine x minus 1 equals 0, which means 2 sine x equals 1, which means sine x look at your unit circle there that's on your sheet, and you should know where sine is a half. Could be pi over 6 and 5 pi over 6. Did you get that from your unit circle? Square brackets mean 0 and 2 pi are both included. Okay? Any questions on that one? Mm-hmm. Look at your unit circle. Look at the coordinate points. Look for 1/2 positive in the y line. Yeah? Yeah, the 45 would be 0.71. But and then so this is how you remember. 30 is 0.5 for sine, 60 is 0.5 for cos. And then they flip on the √3/2. Okay. All right. So this one is like the other one, but when you move the 1 over and divide by 2, some of you are going to lose marks on this, and I'm going to tell you why on the side so that you don't. Remember, if x squared is equal to 25, x is equal to plus or minus the square root of 25. So x is equal to plus or minus 5. Yeah? So when I take the square root of both sides, sine x is equal to plus or minus radical 1/2. That means 1/radical 2. Thank you, Miss. And so if you look at 1/radical 2, remember we're going to rationalize that. We're going to multiply by radical 2 over radical 2. This is going to give us plus or minus radical 2 over 2. So what that means is you're going to look at your unit circle and you're going to find all the y values that are radical 2 over 2 plus or minus. So here's your unit circle. This is positive 1 over, this is positive root 2 over 2. This is negative root 2 over 2. Again, I'm talking about the y value. So by now, you figured out that this first one is pi over 4. This second one is 3 pi over 4. This one is 5 pi over 4. And this is 7 pi over 4. So if you really spend some time with that unit circle, there's so much that you can do a lot easier than the way we used to teach it, which was, oh, children draw this triangle. Oh, other triangle is here, draw it. There's a, if you, all the information is there. All of those identities that you proved, they're all in that unit circle. And once you know the coordinates and you're familiar where it's positive and negative, yes, I can. Because you'd find them in that order anyway, right? So now our answer is going to be x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. You have to remember all of these things that you're doing, because with exact value, we know what the points are. When we go to approximate value, you have to take these radian values and minus them from everything. So just so that we can understand that when we do it in that case. You see this pi over 4? That's my related acute angle. That's the one that gives me the ratio I want. This 3 pi over 4, the way I got it is pi minus pi over 4. That's why it's this one. This is pi plus pi over 4. This is 2 pi minus pi over 4. You need to remember that because now we are being blessed by looking at exact values so we can see them on a unit circle. The next stage is, inverse sine of 0.5 gives us 0.29 radians. So 0.29 radians is here. This one would be 3.14 minus 0.29. This one would be 3.14 plus 0.29. This one would be 2.14 minus 0.49. I'll show you that when we get into it. But for now, it's useful if you could see that those angles are there in even the exact values. So cosine squared x so this is where decomposition comes in. Minus 2 times 1 is minus 2. Two numbers that multiply to give me minus 2 and add to give me minus 1. So I can factor this. I can say cosine squared x minus 2 cosine x plus 1 cosine x minus 2 equals 0. Cosine x times cosine x will give me cosine squared x. Cosine x times negative 2 will give me negative 2 cos x. Plus, take the sign. 1 divides into 1 and negative 2. 1 times cos x, 1 times negative 2. So you've got cos x minus 2, cos x plus 1. So what does that mean? Well, that means this thing is telling you that cosine x equals 2. This thing is telling you that cosine x is equal to negative 1. Now look at your unit circle. Is there anywhere on that circle you have an x coordinate that is 2? Is there anywhere on that circle that the x coordinates are bigger than 1 or smaller than minus 1? Because cosine only goes from negative 1 to 1. So when you have something like this, cosine x equals 2, it's like taking the square root of a negative number. Cosine x equals -1. X must be equal to 5. How do I know, sir? Well, look at your unit circle. Where do you find an x value of -1? That's at 5. Okay. Oh, we'll do the last question tomorrow. There's only 3 minutes and I don't want to fight with the prayer.